In this video I'll do section 12.1 from chapter 12. Chapter 12 is about statistics. Okay, statistics is chapter 12, and the first section, chapter 12, is 12.1, which is about sampling, frequency, distribution, and the graph. And this is basically the section which talk about much more definition and the counting technique in this section. Therefore, this section is, I should say, rather easier to understand than other sections. We don't have to do that many math here. Okay, let's start with the definition of statistics. All right, statistics, statistics. What's the statistics? It is a method. Okay, let me write the definition. It is a method, and I'll explain that. Method of collecting, organizing, analyzing, right? Analyzing, and interpreting data, as well as drawing conclusion based on the data, whatever you collect, right? Based on the data. Therefore, the statistics is a method of collecting, organizing, analyzing, and interpreting the data. Besides that, we also draw the conclusion based on those collected data. That's the statistic. Okay, now for statistics, we mentioned in this section when it's called descriptive statistics, Rather, it's called inferential statistics. INFERENTIAL, inferential statistics. What's the difference between these two? Descriptive statistics only concern about collecting, organizing, summarizing, presenting data. Only it does is collecting, organizing, summarizing, summarizing, and presenting data. That's the descriptive statistics. And the inferential statistics does, what it does is to make a generalization. Make generalization, and draw conclusion from the data. Conclusion from the data. In other words, what the descriptive statistics is concerned about is collecting, organizing, summarizing, and presenting the data. But here in inferential statistics, does is we make generalization of the data and we draw the conclusion from the data. We see something from the data, the conclusion from the data. That's what the inferential statistics does. Now other term here is in this section is called population, and sample. Okay, population sample. Other two terms we need to know in this section is population and sample. Okay, think about, consider the set of all American TV household, right? Okay, consider the set of all the people in America who has a TV. Okay, think about the group. Okay, that set of the people, I mean, who has TV in their home, is called population. In other words, the population is a large group of people, or the population consists of, okay, the population consists of all the people or objects whose property are to be described and analyzed by data collector, right? Therefore, population is a large group of people or object which property are to be described and analyzed by the data collector. I mean, the data collector collect the data to say something about the population, large group of people. But since the group is big, the data cannot be collected from every individual from the population. Okay, then what you do here is we draw the sample. In other words, to study the characteristics of the population, to study the property of the population, we have to study the sample, and we draw the conclusion from the sample about the population. Therefore, the sample here, sample is subset or subgroup of population of the population. Okay, and in this case it would be appropriate to have sample of few household, TV household, to draw the conclusion about the population TV household. Therefore, if you want to draw the conclusion about population TV household, we collect the data from the sample TV household and we draw the conclusion for population TV household. Therefore, population is the larger group which property has to be analyzed by the data collector. And another word here is random sampling. Random sampling. What is random sampling? We know we draw the sample from the population, but when you draw the sample must be done random way. That's called random sampling. A random sample is a sample obtained in such a way that every element in the population has an equal chance of being selected from the sample. Remember that. Every element in the population has an equal chance of being selected in the sample. That's called random sample. Does it make sense to you? Okay, let's do the questions and from the homework. We start from question number 1. Question number 1. The government of the large city need to determine whether the city resident will support the removal of the city university. Okay, we are trying to know whether the city residents, remember that city resident here is the population. City resident is the population, right? And we want to know about the population. That means we want to know whether the city residents will support the removal of the city university. That's what we want to do, is we want to study about the population. That means the city residents are the population. The government described to conduct a survey of a sample of city residents, right? Because you cannot survey every people in the city. Therefore, we have to draw the sample. And the question is, which one of the following procedure would be the most appropriate for obtaining sample of the city residents? That's the question. Number 1. Survey a random sample of students and employee within the university. No, because if you just choose the person from the university, right, that's not going to be random. Therefore, this is called biased sampling. That doesn't work. Second answer, survey every third person who walk into the local grocery stores. That's not going to be random either, because not every type of person can walk in the particular local grocery stores, right? We don't even know what kind of grocery store is that. Well, this is not random sample either. Part C, survey the last 100 residents listed in the telephone directory. Last 100 residents listed in the telephone directory cannot be random either, right? Therefore, maybe this is the right answer. Survey a random sample of person within each geographical region in the city. Yes, you have to go in each geographical region of the city. For example, you might go different zip code of the city, right? That could be random samples. Therefore, the answer in this question is the last one. The survey a random sample of person within each geographical region of the city is going to be appropriate way to do the sampling. Okay, number 1 is finished. Question number 2. A questionnaire was given to the students. The first question asked was, how stressed have you been in the last week on the scale of 0 to 10? 0 being not stressed at all, 10 being as stressed as possible. The response are shown in the table here. See, stress rating, frequency. Now we have another word, frequency here. What do you mean by frequency is, in the survey from the students, 0 stress rating frequency is 4. That means 4 people have, that means 4 people has no stress at all. That's what I mean. Similarly, the frequency is how many object or people on that survey. Here, frequency of 1 is 2, means 1 is stress rating. That means 1 is least stress. Remember that. 0 is not stress, 1 is a little more stress. 2 is more as the go stress. 10 is the maximum stress, right? Therefore, in this question, 2 people has minimal stress, or 5 people have stress 2, and 14 people has maximum stress 10. Therefore, this frequency is number of people having such stress, right? Okay, first question, which stress rating describes the least number of students? Remember that least number of students is what? 2 here. 2 is least. Therefore, which stress rating? 1. The answer is 1. 1 stress rating describe the least number of students. 1 out of 10. Remember that. 1 out of 10. Remember that the stress rating is up to 10. 1 out of 10 is a least number of students has a stress rating. How many students respond with this rating? Remember that. With 1, 2 students response. Okay, that's the answer for question number 2. Question number 3. Similar question here, but different numbers, different frequency. See the 0 is rating 4 frequency, 1 is rating 3 frequency, but it's 2 here, but the similar question. The questionnaire was given to students in an introductory statistics class during the first week of the course. How stressed have you been in the last 2.5 weeks? On a scale of 0 to 10, 0 being not stressed at all, 10 being as stressed as possible. The students responded are shown in the frequency distribution. How many students were involved in this study? That means what you have to do is, that's number of frequency here is total number of students. You add them total. Therefore, if you add all these numbers, you get total frequency equals to 172. Okay, if you add all this frequency, that's the total number of frequency. That's what that many people are in the survey. Therefore, how many students were involved in the study or in the survey? 172. Okay, that's the question number 3. Question number 4. A random sample of 30 college students is selected. Remember that there's a 30 number here, and this is called data. Okay, this is called data, and this is called data item or data value. Okay, therefore there are how many? There are 30 data value. Okay, 30 data values. Listen, 19 is the data value, 15 is the data value. Therefore, there are, for example, 19 is a data value. Make sense? 19 is a data value. Similarly, 15 is a data value. Okay, now the question is, construct the frequency distribution of the data. In other words, remember that there is a 30 different data, but a couple of data repeats. For example, look at the 15 here. How many 15 here? Let me circle the 15 here, 15 here. Where is 15? No more 15. 15 here. See, therefore the 15 repeats 3 times. 15 repeats 3 times. Therefore, the frequency of 15 is 3. Correct? Now, if you look for 16, let me highlight 16 here. How many 16 on this data? 16 here. 16 over here. That's all. Therefore, the frequency of 16 is 2. Therefore, every data value has a frequency. Similarly, 17 has a frequency 4. You can count. 18 has a frequency 4. 19 has a frequency 3. 20 has a frequency 5. 21 has a 2. 22 has a 2. 23 has a 3. No, 23 has a 2. 23 has a 2. Because look at 23. 23 here. And 23 here. Okay. 23 has a only 2. Okay. 24 has a 3. 25. 25. There is no 25 in this data. 25 has a 0 frequency. Now if you add 3 plus 2, 5 plus 4, 9 plus 4, 13 plus 3, 16 plus 5, 21 plus 2, 23 plus 2, 25 plus 2, 27 plus 3, 30. When you see 30 is the total number frequency, the question is, that's the frequency distribution. That is called frequency table, or is also called frequency distribution of this data value or data set. Okay. Question number 4. Question number 5. A professor had his students keep track of their social interaction for a week. The number of social interaction over the week is shown in the grouped frequency distribution. Remember, this is the grouped frequency distribution. Grouped. Group in the sense that, see, from here to here, from 35 to 39, 40 to 44. See, that's called grouped frequency distribution. Because you have a group. That means 35 to 39 is one group between these two numbers. And this group is called class. Okay? This is the class. And that's the first class. First class. What's the second class? The second class is going to be 40 to 44. Remember that. This is number of interaction between 35 to 39. In other words, what do you mean by frequency of this class? First class is 12. That's the question. What do you think? That means 12 students has a number of interaction between 35 to 39. Okay, and in this class, first class, I should say this first class, this is the lower class limit. Lower class limit. And this is the upper class limit of the first class. Upper class limit of the first class. Okay. Similarly, 40 is the lower class limit. 44 is the upper class limit for the second class. And the question is, what's the lower limit of sixth class? Which one is sixth class? 1, 2, 3, 4, 5, 6. This is sixth class. What's the lower limit? 60. Therefore, lower limit of the sixth class is 60. Question number 6. The professor had students keep track of the social interaction for a week. The number of social interaction over the week is shown in the following grouped frequency distribution. Again, this is similar to question number 5. It's also grouped frequency distribution. Okay, what's that called? Remember that this question number 4 is called just frequency distribution. Frequency distribution. Okay, frequency distribution. But this is called grouped frequency distribution. That's the grouped frequency distribution. And the question is, what is the class width? Okay, what's the class width? Okay, remember that to find the class width, what you have to do is you subtract. You subtract 2 consecutive consecutive, consecutive lower or upper class limit. In other words, consecutive means next to each other. 25, 34, you subtract. Either you do 34 minus 25, which is going to be 9, or you can do 42 minus 33. Remember that upper class limit. 42 and 33, they are the consecutive upper class limit, which is going to get 9. Therefore, doesn't matter how we do it, the class width is 9. Oh, my bad here. I should say question number 7. A professor had students keep track of their social interaction for a week. It's similar to other questions but different frequency distribution. Okay, and again, this is the grouped frequency distribution. You can see on the right, grouped frequency distribution, and the question asks you among the classes with the greatest frequency. Okay, classes with the greatest frequency. That means you see the greatest frequency here is 19, 19, 19. That's the greatest frequency. You have 3 classes with the greatest frequency, right? 3 classes with greatest frequency. With the greatest frequency. Okay, and the question asks you which class has the least number of social interaction. Remember that this least number of social interaction has this class 30 to 34 social interaction. That's the least number. Then compare to 35 to 39, 40 to 44. The answer is this class 30 to 34. The second class has the least number of social interaction. The answer is Z, 30 to 34. Okay. All right. Question number 8. As of 2011, the following are the ages at which the country president were inaugurated. That's the age. How old are they when they are inaugurated? Okay, this is the data. This is the data, and each number is called data item or data value. How many data value? It doesn't say how many, but we can count it, right? But when I find the frequency, I add that's total number of frequency going to be total number of data item. Okay, and the question asks you construct a grouped frequency distribution for the data. That means you construct the table like question number 7, 6, and 5. Okay, and use 41 to 45, this first class, and use the same width for each subsequent classes. Yes, remember that each class has the same width. You can see that. Okay, but you don't have to write the class. That is already given. You just need to find the frequency. Okay, what is frequency of this class? And the question is how many president were in the age group 40 to 45 inclusive. That means you're looking for the number between 41 to 45 inclusive and count how many are there. For example, let's count the first one, 41 to 45. 41 to 45. Let's put the circle here. 41 to 45. let's see, 43 here, 1, 44, 2, 43, 3, 42, 43, 44, 45. Notice that 45 must be included as well because it's inclusive. And 44 here, and anything here, and that's all. So for that we have 1, 2, 3, 4, 5, 6, 7, 8. So there is 8 data values between 41 to 45 inclusive. For the frequency of this class going to be 8. Similarly, what's the frequency of second class? Let's do that. Now second class, 46 to 50. Look at 46 to 50. How many numbers are in between 46 to 50 inclusive? Okay, 46 to 50. 46 here, 1. 46 to 50. There is something here. $48 here to 50 here 3, 50 here 4, 50 here 5, then 49 here. That means 6. Okay, therefore the class 46 to 50 has a frequency 6. Similarly, you can count for all classes, and 51 to 55 has a frequency 9. 56 to 60 has a frequency 8. 61 to 65 has a frequency 9. 66 to 70 has a frequency 4. Okay, that is called a grouped frequency distribution table. Okay, that's the answer. And if you want to make sure that this total number of frequency, if you add this, all this number, you don't have to do here. 8 plus 6 plus 9 plus 8 plus 9 plus 4, which gives you 44. Therefore, if you count here number of data, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 plus 8, 36, 37, 38, 39, 40, 41, 42, 43, 44. So there is 44 data values, right? That's what the total number of the frequency is going to be. Excuse me, that's the question number 8. Question number 9. Okay, the question number 9 is the same type of data as a previous question, stress rating. Okay, but in this question, you got to represent this data into a histogram, construct a histogram and a frequency polygon. Okay, I'm gonna show you what's the histogram going to be. Histogram is a bar graph. Here you see the graph of this data set. You can represent this data set also as a graph, that is called histogram. And in this, along this horizontal line, you have a data value 0, 1, 2, 3 up to 10, and this way goes to frequency. Okay, and if you read the graph carefully, for example, most of the people are stress rating 8, 32 people. Therefore, if you look at the 8 here and look at the height of the bar graph, which is going to be 32, you see the match 32. Okay, therefore if you check everything here, for 0 there's 2. Therefore, see, for 0 stress level you have 2 people, 1 stress level you have 3 people. And here look at the frequency here. And if you check carefully, this number for A is the answer for the this question A. Okay, I said the first response is the correct answer, other one not. For example, if you look at this part, the second response, answer response, remember that, see, the 8 has a frequency, how much is almost less than 5, but that's not correct. 8 has a frequency 32, that's not correct. Look at here, for the 8, what's the height? Oh sorry, is less than 10, but you have 32 frequency for 8. And even for this one, similar reason, this not correct answer, because this data doesn't match with this graph. Even this one here, it is looks okay, but if you look at the frequency of 3, 20, right, has to be, but look at here, the frequency of 3, not 20, it's less than 5. Therefore this is not the correct answer. Therefore the answer is this one. Okay, so you pretty much match this data with the frequency on the graph to see which one is correct. Okay, now construct the frequency polygon. What you have to do is this. Since this is the correct histogram, it's called histogram, you find the midpoints of each bar here. Okay, to find the midpoint of each bar. Okay, now you connect those midpoints by the line like this. Start from origin like 0, connect like this. All right, it has to be a straight line, not by the curve. Like this. Therefore this is the graph here, which is connected each middle points of this bar. It's called frequency polygon. Therefore if you match carefully, the frequency polygon here must be this answer. Why? If you look at here, look at this peak here, this is for 3. For 3, stress level is 20. That's we match here. Okay. For 8, stress level is 32. You can see that for 8, stress level is 32. Okay, so it's just above 30. Then this supposed to be 32. But this part is incorrect, because look at the first, for 3, stress level is 0, right? But it's here 20. That's not correct. Again, this D is not correct, because for D, for 8, stress level is 0 on this frequency polygon. But here in the table, for 8, frequency for 8 is 32, but this says 0. Therefore that's not correct. Also this is not correct, definitely, because it doesn't look like this graph. Therefore answer is this one. Okay, that's how you construct histogram and frequency polygon for the data. Question number 10. The frequency polygon to the right shows a distribution of IQ score. Determine if the following statement is true or false according to the graph. This is a graph. Graph is based on a sample of approximately 50 people. What do you think? Okay, this is the IQ score. This is the IQ score. Notice that this whatever IQ score here for this points, for example, it's like 105, because 110 here, 100 here, this is 105. This frequency is 20, that's 25. The frequency of this data is 25, right? And the frequency of this is going to be maybe 27 approximately. You don't have to be exact. and frequency of this gonna be 20, this gonna be 20, right? In other words, if you add the frequency, obviously more than 50, okay? Therefore, this frequency distribution best not on the sample of approximately 50 people, has to be more than 50. Obviously, you can see that this 2 data value has a frequency add up to 50 already, and you have more frequency has to add. Obviously, total number of frequency is going to be more than 50. Therefore, no, answer false, because the sum of the frequency is greater than 50. You understand what I'm saying? Okay, notice that this number of people is frequency in this way. We already have 50 frequency with this 2 data value, and still we have more, therefore add up to more than 50. Therefore, sample is not based on 50 people. Okay. All right. A random sample of 40 college professors is selected from the all professors at the university. Number 11. The following list gives their age. Construct the stem leaf plot for the data. We are doing new item here. Stem leaf plot. Okay. Let's say, what is stem leaf? Data, let's say data is 69. All right. This is the data, one of the data. And in this data, 6 is called stem, and 9 is called leaf. Therefore, every data has stem and leaf. And you guys see that for 69, 6 is the stem, 9 is the leaf. 41, 4 is a stem, 1 is a leaf. And 65, 6 is the stem and 5 is the leaf. Okay, therefore, you see in this data, only have a stem 2, 3, 4, 5, 6, right? 2 here, stem, 3 here, stem, 4 here, stem, right? That's what you got to do. All right, now to determine the leaf, you got to read the second part, right? The first place. Remember that. L-E-A-F, not L-E-A-F-T. L-E-A-F. Okay, let's find the data with the stem 2. Let's find the data with the stem 2. Let me read that for you. 25 here, 28 here, 22 here, 23 here. That's the okay. Therefore, how many data you have a stem 2, 1, 2, 4 data. There are, let me write down something here. There are 4 data with a stem stem 2, right? And what's the leaf? Leaf for those data are going to be leaf for those data are going to be 5, 8, 3, 2. Okay, see, 5, 8, 3, 2. 5 is the leaf, 8 is a leaf, 2 is a leaf, 3 is a leaf. And now you type this number here. Use ascending order. You write smallest to largest. Therefore, when you write the data, you write 2, 3, 5, 8. Okay, don't leave a gap. Just type all together like 2358, 2, 3, 5, 8, but in ascending order. Okay, that's what the first box gonna be, looks like that. For the 3, if you look at the 3, let me highlight the data with the 3 stem, 32, 38, 38, 33, 36, 34, 35, 33, 37. Let's see how many. Anybody miss any one of those? That's pretty much. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. No. I'm sorry. I missed 37. We have still 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. For 30 for stem 3 leaf R. What do you think? Leaf R. Let's see. 2, 8, 8, 7, 3. Let me write down here. 2, 8, 8, 7, 3, 6, 4, 5, 3, 7. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. But when you write the leaves here, you have to write numbers, all the numbers in order. You have to type all. Right? Let's start as small as 2 here. 2. And other number is 3. But you have 2, 3 here. You have to type both 3. 3, 3. But no gap. Just type all together. 2, 3, 3. And what's the next biggest number? 4. 4 here. Next one is 5. And 6, 7. You have 2, 7. 7, 7. 8, 8. 8, 8. That's how you type. For a stem 4, your leaf is 1, 2, 2, 1. But if you put in order, I'm not gonna count like before. I'm gonna write the you guys pause the video and find the leaves and see did you get same as mine. Okay, let me write type for you. 1, 1, 2, 2, 2, 2, 2, 3, 5, 5, 6, 6, 7, 8. Okay, that's for stem 4. For stem 5, leaf are 1, 2, 2, 2, 4, 6. For stem 6, the leaf are 1, 2, 5, 5, 8, 9. Okay, that's how you type. Make sense? Pretty much this data tells you this stem leaf plot tells you we have a data 23. If you don't look at the data, don't look at the data. Still you can find the data. The data are 22, 23, 25, 28, 32, 33, 33, 34, 35, 36, and so on. Therefore, stem leaf, as long as you have a stem leaf plot, you can find what are the data. That's what it's for. Part B. What does the shape of the display reveal about the ages of professor? Then the stem plot determine that. Remember that the greatest number of college professors are in their 40, because see 41, 41, 42, 42. There is many college professors in this data are in the age of 40. Okay, therefore answer is B. The greatest number of college professors are in their 40. That's the answer. Okay, that's the part B. Part C. Describe what is the misleading in the visual displays of the data. Okay, that's the question. Question number 12. Describe what is the misleading in the visual displays of the data below. If you look at the visual display, it's the world population in billion. In 904 there is 1904. Well, then the 1804 there is 1 billion population. 1927 there is 2 billion population. 1963 billion population. 74 4 billion population, and so on. And this is the visual display. But what is misleading here is, if you look at the time interval here in this horizontal axis, these are not equal. In other words, if you see the difference between 9027 and 9060, that's more year difference between 9060 and 9074. Okay, that's why this is misleading, because the time interval on the horizontal axis do not represent the equal amount of time. Okay, question number 13. Describe what is misleading in the visual displays of the data below. Visual display here is, as long as you see the pie chart here, the each section represent some percentage must be add up to 100. But if you add all this percentage here, do not add up to 100. You can try by adding yourself. Therefore, this is misleading here, is the percentage do not add up to 100% in the pie chart. This is called pie chart. Other visual display of the data is called pie chart, and each section of the pie has to be added up to 100%, but here it doesn't. Therefore, this is misleading. Okay. Question number 14. Determine whether the statement makes sense or does not make sense. Explain your reasoning. A public radio station to survey its contributors to determine their programming interest. That's what the public radio station want to do. So they should select the random sample of 100 of their largest contributor. Okay. Therefore, to survey about the programming interest, if they randomly sample 100 of their largest contributor, that's going to be biased. Therefore, this doesn't make sense, because the sample must be included all the contributors, not only the largest contributors. Okay, make sense? That's the answer for question number 14. That's all about this 12.1. Thank you. 25 here. I said 25, but write 35. Okay. Okay, that's the question number 6.